For the final page, we have two more sets of problems. We're going to work first on the top one, so we're doing 8A. It says data suggests that randomly selected college students eats breakfast at a 0.550 probability. If 5 students are randomly selected during determine the probability that the 4th student selected eats breakfast. So if we have 5 students, 1, 2, 3, 4, 5. Forget it. If we have 5 students, what's the probability this guy eats breakfast? Well, these guys, whatever they do doesn't matter. It doesn't affect this person's probability of eating breakfast. So the probability that this person eats breakfast is 0.550. It's almost like a trick question. Okay, so we just have to factor in that it doesn't really matter what the other guys do. It only really matters that every individual person has an independent chance of 55% of eating breakfast. So that's the first part. Part B, it says if 5 randomly selected students, if 5 students are randomly selected, determine the complement of the statement, at least one of the 5 students eats breakfast. So the complement to at least one is none of the 5 students eat breakfast. And that's what I'm going to be looking for. I'm going to be looking for a statement, so you should be able to type that out or something similar to that to answer that question. Then next is determine the probability of the complement statement. So determine the probability that none of the 5 students eat breakfast. 1, 2, 3, 4, and 5. What the? Okay. Yeah, I thought that was a circle. That's pretty bad. Anyways, that means I'm just drawing horrible. So what's the probability that this person does not eat breakfast? Well, if it's a 55% chance they do eat breakfast, then it's a 45% chance this guy doesn't. It's a 45% chance he doesn't, or she, for 45%, 45%, 45%. So it's a 0.45 to the 5th power chance they don't eat breakfast, which is a 0.45 to the 5th, 0.0185. So there's a 1.85% chance that not one of the 5 students eats breakfast. And therefore it says using the part D, this would be your answer for this one, obviously. And then for part D, it says using the probability from part C, determine the probability that at least one of the 5 students eats breakfast. Well, remember the probability of 0 plus the probability of one of them eating breakfast, 2 of them eating breakfast, 3, 4, and 5. Probability of each of those events happening is 1. It's a 100% chance that either 0, 1, 2, 3, 4, or 5 of them eats breakfast. We know this value. We know that this portion represents P, that X is greater than or equal to 1. So if we do 1 minus P of 0, none of them eating breakfast, we get P of 1 all the way to P of 5. Which this is obviously the at least one eats breakfast. And so therefore 1 minus 0.0185 is 1 minus 0.0185, 0.9815. So there is a 0.9815% chance. No, sorry, not percent. 0.9815. So that's a 98.15% chance that at least one of them eats breakfast. Okay, so we're done with that. For part 9, you can either use the calculator or you can use the formula. We have 22 times 21 times 20 times 19 times 18 times 17 factorial. 17 factorial over 2 factorial, cancel. 2 goes into 20 10 times and multiply these things out. Or we can go and simply do 22 math. Oops. Divided by 17 math times 2. I know that that's just 2, but I'm doing it just in case you don't understand that 2 factorial is just 2 times 1, which is 2. And your answer would be 158,0040. Okay, that would be our answer for this one. And then for part B, this is part A. Part B, we have 6 factorial times 2 factorial minus 2 factorial, 2 factorial, which is 720 times 2 minus 2 times 2, which is 1440 minus 4, which is 1436. So I hope that that works. Obviously, you can use a calculator if you need to. I may throw in some special factorials, so make sure you know the special ones that we talked about in class. I hope you guys are practicing and you guys take this review and sort of run with it. Thank you guys for your time. Make sure that you guys study. Have a good day. Goodbye.